Hello everyone and welcome to this Nohau Solutions webinar. My name is Björn Skånberg and I work as Field Application Engineer here at Nohau Solutions. So this is session 1, getting started with Keil MDK. So for today I will start with giving you 2 minutes on Nohau Solutions and who we are and what we provide. I will then go over and give an overview of Keil, so what different versions are there. I will share with you the news that are in Keil, so both for the microvision, the compiler, but also new debug probes. Then I will go over to a hands-on demonstration, so I will show you what you need to get started, what pieces of software, and where you can collect them. And then I will end with a Q&A. So if you have any questions during the webinar, please write it in the chat box and I will answer them at the end. Tomorrow, same time, I will go over debugging. So debugging and also trace, both ITM and ETM. Then I will go over the RTOS awareness and the event viewer. And then I will end with a hands-on demo of everything and a little bit of tips and tricks on how to debug and trace your embedded system. So let's start with a few words about Nohau Solutions and who we are. So we supply the Nordics with solutions in the embedded field. So we have 3 offices. Our main office is in Malmö, where I'm located. We also have office in Copenhagen and in Helsinki. So we are about 18 employees all in total. So we provide solutions from these market-leading suppliers. So today I will talk about Keil, which is a tool by ARM. We also have debuggers from Lauterbach and Seger, static code analysis tools from Grammatech and PRQA, unit testing tool from QA Systems, Bluetooth analyzers from Frontline, just to mention a few. So hopefully these are more or less known to you. So back to the Keil MDK. So there are 4 editions available for Keil MDK-ARM, and the first one is the free version, which is called Lite. Lite has support for Cortex M0 to M7, so those cores that are called ARM v7, and it has a restriction for 32 kilobyte of code, so you're only allowed to compile 32 kilobyte of code. It comes also with the Semsys RTOS RTX with full source code. One step up is the Essential, so MDK-ARM Essential. This was known as the Cortex M version, but has now switched name to Essentials. So for those of you who has the Cortex M version, you will get an automatic upgrade, so to say, to the Essential version. So you don't have to do anything to change this. So it has support for the ARM v7 cores, but also it has support for the non-secure part of the M23 and M33. And this is the new Cortex cores from ARM, which includes the trust zone for Cortex M. So if you go one step up, then we have the Plus version. So the Plus version, it has support for well, the Cortex M, but also if you're looking for developing softwares for the heterogeneous system, so if you're having an IMX7, for instance, it has support for both the Cortex M and the Cortex A part. You have support for the secure and the non-secure part of the trust zone. And you have the first level of middleware. So if you're doing a project where you need IPv4, USB device, a file system, or graphics, you can use the middleware from Keil in your project. So this is more or less plug and play. So this will cut the time to market rapidly if you need those type of things. Then we have the professional version. So the professional version is, well, the full-blown version. So you have the IDE and the debugger, and also you have the fixed virtual platforms. So if you're looking to develop code on a core which there is not silicon for yet, so for instance the Cortex M23, M33, then you can use the fixed virtual platforms to do so. You also have support with the MDK, so for the heterogeneous system, support for all the different cores, and you get the middleware, the middleware level 2, so IPv6 network, USB host stack, and IoT connectivity encryption package. So this is available in the Pro package. So also for those of you who are looking to do functional safety, it comes with the extended maintenance and qualification kit. So as you might have heard, there is a new compiler out now, which is ARM Compiler 6. And for ARM Compiler 6.6, it has been certified. So it has been certified with TÜV Süd. So this is for those of you who are looking to do functional safety projects. So if you use the certified compiler, then you don't need to qualify this when you qualify your product. So the compiler and the tool chain has already been qualified. So the business model is the same. So it's part of the MDK Pro and the DS5 Unlimited edition. No change there. But we have also added a new product. So the ARM Compiler 6 can now be bought as a standalone product. So this is for those of you who are looking to do functional safety, but do not need the middleware. So for those, you can buy it as a term license or perpetual license, and there is no minimum quantity. So one compiler is enough. So if we do a short comparison between the compilers, so for the ARM Compiler 6.6, you have both functional safety for automotive and industrial, but also for medical and for railway. And these goes for all the different integrity levels that there are. Also, if you're looking to do code for the ARM v8, so the M23, M33, you can use the ARM Compiler 6.6. Also, there's a new feature that comes within ARM Compiler 6, so quite a big difference from ARM Compiler 5. And this is called the link time optimization, or the LTO. So the compiler is looking at optimizations not only within one module, but also between module to module. So this will result in reduced code size, both for ROM and ROM, and also quite a bit speed up in the performance of the executable. Also, the GCC compatibility has been increased. So for those of you who are migrating from GCC to ARM Compiler 6, this is now much easier. So again, it comes with the MDK Pro, but you can also buy it as a standalone product. If we go into MDK-ARM now and the microvision, so there has been added RTOS awareness for FreeRTOS. So for those of you who are using FreeRTOS in your product, you can now get the same type of debug awareness as you can with the Keil RTX. So to make short explanation, so going from left to right or going from right to left is now quite easy. Keil has also added a component viewer. So this provides human-readable information about the complex data structures that can be in a software component. So this is available for the Keil RTX, also the FreeRTOS, and also for the MDK middleware. So if you're, for instance, using the IPv4 stack and you want to see the status of your stack, you can add this view and get performance or seeing how it's doing, so to say, with this view. So it makes debugging the middleware very much easier and seeing the configurations that you have made. So if you have your own kind of component that you wish to create a view for, you can of course create these type of views yourself. So it's an XML based format that you need to write. So this is available for every debugger, so even the third-party debuggers, and all you need is the JTAG or the serial wire debug. So no trace is required to get this type of view. So it works on every ARM Cortex M core. I will show you more about this tomorrow. There's also something called the event recorder. So this can give you, this is a kind of message passing. So it can give you dynamic behavior of the software. You can get messages on what your real-time operating system is doing, or you can of course write these type of messages yourself. So this is, so when you do this, you are able to filter the messages as in runtime. So this means you don't have to do this at compile time. So when you are in runtime and you're only interested in certain things, you can filter out the messages that you are interested in. Also, what's worth mentioning is that the event recorder calls are non-blocking. So this means that they can stay in production code, and if you find some nasty bugs after releasing your component, you can quite easily turn the messages on via the debugger. So this is also available for every debug unit, and it works via the JTAG or the serial wire debug. So no trace is required for this, and it works on every ARM Cortex M core. There is a new debugger in town. So it's a debugger called ULINKPlus, so ultra compact high-speed debug probe. So this gives us the possibility to do power profiling of our application. So we can actually measure the power that our system is taking during execution. Keil has also put some I/O pins on this debugger, and this is for those of you who are looking to add this debugger in the test automation system. So if you need to interact with some I/O, you can script this from the debugger, and the debugger can send this to your target. So if we have a look at the ULINK family, we have the ULINK 2 to the left, and we have this ULINKPlus, which comes in between ULINK 2 and ULINK Pro family. So it has, well, it has the serial wire trace as the others, but it also has the power measurement and the test automation capabilities. So energy measurement and logical IOs. So for those of you who are looking to do instruction trace, you need to buy the ULINK Pro. But if you're looking for just the serial wire trace, then the ULINKPlus can do the job, so to say. So for contact information, so if you have any technical questions, please contact me. Or if you have any sales questions, please contact one of my coworkers. So for today's hands-on, I have a Keil eval board, and it has a Cortex M4 from ST on top of it, and I'm using the ULINK Pro to debug and flash it. So I have prepared and downloaded software for this board before I started this webinar. So because I'm using a STM Cortex M4, I have downloaded the device family pack for that. If I were to use the middleware component, so USB, graphics, or Ethernet, I have also downloaded the middleware. And since I'm going to use the Keil RTX RTOS, I have downloaded the SEMSys software component pack. Okay, so we see, so this is my setup. So the ULINK Pro and the eval board. And let me open the Microvision 523. So we say project, close project. Okay, so first of all, let's have a look in the pack installer. So the pack installer is showing me, well, it's showing me which devices that we have support for. So at the moment, it's around 3,900 different Cortex M devices. So if you were to start your product development and you develop on a, let's say, an STM, and you for some reason discover that, okay, we must switch to NXP. This is quite easy if you have the MDK-ARM, because you're not locked into any specific silicon vendor. You can switch quite easily during the project. We also have quite much support for the different eval boards that are out there. So if we have a look at my eval board, which is the MCB STM32F400, I see which packs are available. So I have downloaded the device family pack for the Cortex M4 from ST, and this is the versions I have installed. If I'm doing some bug fixes for some older project, I can of course go ahead and download the older device family packs if I want to. I have the SEMSys, so where the RTX and the SEMSys is, and I have the Keil middleware. So saying there I have the different versions, and I can go older if I need to. Okay. So also there are usually some examples for each evaluation board. So I recommend you, so when you're going to start your project, go in and have a look at the examples, because usually there are an example that could fit as a starting point for your project. So for instance, if I'm going to do a USB device HID, I can use this project as a starting point for my product. So you don't need to worry about setting up the USB communication, because this is already done in this example, and it's working out of the box, so you can concentrate on actually developing your algorithms and so on. So have a look in here before you, when you start your project. Okay, so let's go ahead and create a new project. So we say project, new Microvision project, and let's give a new folder called webinar, and we say my project, I say save. So first of all, I need to go ahead and choose the MCU I'm using. So STM-F4 407 IGHX. So I get a little bit information about my MCU. I click OK. So now I will come to the Manage Runtime Environment. So this is a graphical way of adding which software components or what software you would like to add to your project. So if you have, let's say for the USB, you see we have a blue text out here. So if I click on this link, it will take me to the documentation of the USB. So as you can see, the documentation is stored on my hard drive, and I can then go ahead and say, well, function overview, and then get the information that I need for my USB project. So I'm going to go ahead and say that I would like to use the RTOS, so the Keil RTX. So if I tick the box that I want to use Keil RTX, the validation output would say that you need to use the Keil device startup. So MDK-ARM knows this because in all of the software packs that I have downloaded, there is an XML file describing the different dependencies that software components have on each other. So I always know which components I need to make another component work, so to say. So it says I need the Keil device startup. I tick the box, and then to use the startup I need the ARM's MC's core. So instead of going ticking each box in, I can say resolve, and then the runtime environment will add all of these components for me. Let's click OK. So we see now we have a few files added to our project. So if we have a look in the select software packs, I have ticked in the option, or it's by default, use latest version of all installed software packs. And this is all good if it's a new project you're doing. Then you probably want to use the newest software packs. But if you're doing bug fixes and you're doing it where you have used an older version of the software pack, you can of course choose the older versions, so that I'm using 2.5.0 instead of 2.11.0 this time. So if I were to go ahead and save this and save my project, upload it to, I don't know, your version source code, so let's say Git, and then your coworker were to download the same project. So when your coworker opens a project, he will get prompted with the window saying, this project is configured for version 2.5.0, so please go ahead and download this before you do any coding. So this is quite handy for this. But I'm going to go ahead and use the latest versions because this is a new project. Okay, so what I need, first thing I usually need is a main function. So let's go ahead and add that. So I right click and I say add new items to group. So I can either go ahead and add a C file or a C++ file, and then write the main function from scratch, or I can go ahead and use the user code templates. So the user code templates has some templates for the different functions that I would like to use. And again, these comes from the XML file that we have in the software component packs that we have downloaded. So there are described these different templates which we can use. So I want to use the main file, so let's go ahead and add that. I also would like to use a thread, so I will go add new item, and I will go ahead and say user code template, and then thread, and then I can add this. Okay, that's good. So I will go ahead and compile and see that everything is fine. Okay, so everything is fine, that's good. So let's add some functionality to this project. So I'm going to do the blinky just to keep it simple. So first of all, I need to add the drivers for the GPIO and the LED and so on. So this is done from the Manage Runtime Environment. So I click. Because it's an eval board, I have APIs already pre-made. So in the device family pack from ST, there is these functions already made. So if I were to tick the LED box, it has some dependencies, of course. So to be able to use the LED, you need the GPIO. Sounds logical, so I can tick the GPIO, and to use the GPIO I need the common, and so on and so on. So I will click resolve, and then Keil will try to resolve as far as possible. But in this case it couldn't do all the way. So this is because Keil wants to know how would I like to configure the hardware. So I can do this by either the classical way, which is the RT device header file, or use the STM32CubeMX. So because these are equivalent, Keil can't decide for me, so I have to take the decision myself. So I'm going to use the classical. Okay. So we see we have some more files added to our project, and I need to write the actual functionality. So I need the header file for the LED. We say LED initialize, and use control space if you want to have the auto completion. It's gonna make coding a whole lot faster and easier. 0 OS delay, we wait for half a second, we turn it off, and we wait 500 milliseconds. Okay, there we go. So since I'm using the RTOS, I need to configure the RTOS as well. So we go into the rtxconf.cm.c. So in Keil, when we do configuration in either header files or C files or assembly files, they've usually structured it in two ways. So we can either go and edit in text mode. So I can go ahead and edit this define here, or you see that Keil has put in these annotations. So these annotations will create a configuration wizard. So then we have a little bit more graphical way of showing things. So this is usually easier for when you're doing configuring. Makes it a little bit more readable. So if you want to do this yourself for your own project, all you need to do is add these type of XML, and then you can get the configuration wizard. So my MCU is running in 16 megahertz, so I need to alter that, and we save. So let's compile. So hopefully I haven't done anything wrong. Let's see. Wait a little bit. There we go. I think I have forgot something. So I need to initialize my thread as well. So we need to do this from the main file, or I like to do it from the main file. You don't need to do it. And then we say init thread. Okay, so there we go. So now that I have my binary ready, I need to flash it to my target and start debugging it. So I have to go into options for target and choose the correct debugger. So I go to debug tab, and then I need to select the ULINKPlus. So you see there is a few available which you can use. So I'm going to use the ULINKPlus. We go into settings. So we see here that the ID code of the MCU can be read out. So this means I have connection to the target, and I have the trace tab. So the trace tab, if I have the possibility to collect some kind of trace, I will go over this tomorrow very thoroughly. Then we have the flash download. So I need an algorithm to flash my target. So these are pre-made and you can download this. So this comes from the device family pack of the STM Cortex M4 package. And if you have multiple flash, you can of course add multiple flash algorithms. That's about it. Okay, and we enter debug mode, so we flash the target and then enter debug mode. We say run, and our LED is flashing. What a glorious day. Okay, so this is all I had to show you today. So tomorrow I will go deeper into debugging, into trace, and also into kernel awareness and the event recorder. So basically tips and tricks on how to debug your Cortex M system in the most efficient way.